The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 25, Trigonometry, the Circular Functions. We shall now proceed to investigate the metrical relations of figures leading up to the trigonometrical formulae of a triangle. The starting point is found in a relation connecting the arcs of concentric horocycles, and this leads to the expression of the angle of parallelism. The great theorem which enables us to introduce the circular functions, sines and cosines, etc., of an angle is the geometry of the shortest lines, horocycles, traced on a horosphere is the same as plain Euclidean geometry. Let ABC be 3 points on a horosphere with center omega. The planes A, B, omega, etc. cut the surface in horocycles, and we have a triangle ABC formed of shortest lines or geodesics, which are arcs of horocycles. The angles of this triangle are the angles between the tangents to the arcs, or dihedral angles between the planes omega AB, omega BC, omega CA. If the angle at C is a right angle, then the ratios of the arcs are BC divided by AB equals the sine of A. AC divided by AB equals the cosine of A, etc. These circular functions could be introduced independently of the horosphere by defining them as analytical functions of the angle theta. Namely, the sine of theta is equal to theta minus theta cubed divided by 3 factorial plus theta to the 5th power divided by 5 factorial minus ... Cosine of theta equal to 1 minus theta squared divided by 2 factorial plus theta to the 4th power divided by 4 factorial minus ... The unit of angle being such that the measure of a flat angle is pi, 3.14159 ... We may call this circular measure. It could be shown that if ABC is a rectilinear triangle, right-angled at C, the ratios BC to AB and AC to AB tend to the limits sine of A and cosine of A, as BC, AC, and AB all tend to 0, while the angle A is fixed. Chiefly, Chapter 3, Section 18, footnote.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.